Hey everybody, here we go with Common Denominators Part 2. This is Lesson 56, and this is a follow-up lesson for what we did earlier this week with Lesson 55. We just started to get introduced to finding common denominators. This is the exact same idea, just taking it a step further. So basically, instead of renaming one of the fractions in a given equation, we're going to talk about what to do when we need to rename both of them. If you can do one, you can do both. We just have to get a good understanding of what common factors are and go from there. So our learning targets for today are rename two fractions so that they have common denominators, add or subtract two fractions when we do not have common denominators by renaming both fractions, and then if you can do that, you can do this next step easily. Compare two fractions that do not have common denominators by renaming one or both fractions. So it's going to look like, just like it has before, where you are shown two fractions and we're asking you to compare them, meaning we're looking for an answer of greater than, less than, or equal to, and just understanding that you cannot easily compare fractions unless I should reword what I'm going to say. The very best, most accurate way to compare fractions is to give them common denominators. That way you know for sure which is larger or smaller. So we have 6 slides to get through, and let's go ahead and get started. So this is just a bit of review, looking at adding two fractions. And really, this isn't review because in this case, we need to come up with a common denominator for these fractions, and one of these cannot stay. One of these is not a factor for the other, so we need to rename both. I'm not sure why that says review. We can do this. So we start by evaluating our denominators. We have a 3 and we have a 2. So in order to come up with a common denominator for this equation, first of all, we're going to rewrite both of these fractions, and you can do this however it makes sense to you in your head. A lot of times people like to completely rewrite the problem right down here underneath. If that works for you, you should do that. For some reason, I like to rewrite my fractions right next door, and that works for me. So that's what you'll see me doing. If yours looks different, that's okay. So I need to come up with a common denominator that both of these numbers have in common. There are a few ways to think about this. One thing to consider is that actually, if you multiply these two numbers together, that will for sure give you a common multiple. But it's not always necessarily the least common multiple, the smallest one you can use. So that's kind of a place you can start if you're not really sure what to do, and then kind of go from there. So if I were to take 3 times 2, I get 6. 6 is a common multiple of each of these. Yeah, 2 can go into 6, 3 can go into 6. And actually, now that I'm thinking about it, there is not one smaller than that. Sometimes there is, but there is not one smaller than that. I'm going to use 6. I'm going to use 6 as a common denominator for these two fractions. Now, from here, once we determine what our common denominator is going to be, the work is easy. It just takes a few steps. Now I just need to ask myself a few questions. How do I get from 2 to 6? 2 times what is 6? Well, 2 times 3 is 6. 2 times 3 is 6. And I must do the same thing on the top over here. If I do it on the bottom, I do it on the top. So 1 times 3 is 3. Okay, so I've rewritten my fraction over here. I need to do the same over here. I'm not sure why I started on the right. It doesn't matter, I guess, which side you start on when doing this work. How do I get from 3 to 6? 3 times what is 6? Well, 3 times 2 is 6. And whatever I do here in the denominator, I do in the numerator. 1 times 2 in this case. 1 times 2 is 2. Okay. And just for the visual, I like to cross off my old fractions so I don't get confused. I have 2 new fractions to work with. They both have a common denominator that makes my brain happy. I'm going to carry that over. That part is done. I just need to add my numerators now. We have 2 plus 3. and I get 5. And I stop and ask myself if I can reduce it all or if there's anything further I can do, and no. 5 is a prime number. This fraction cannot be reduced. All right. Here's another example. This one's in the form of a story problem, but the exact same idea. Risa saw that she had 3/4 of a carton of 12 eggs. She used 2/3 of a whole carton to make a batch of French toast for her family. What fraction of a carton of eggs were not used? Okay, go ahead and give this a try. Sometimes you need to go back and reread a story problem to really make sure you have the most accurate information. Basically, you know that based on our topic for today in math class, you're going to be adding or subtracting fractions. So keep that in mind and what work you're about to do, and unpause your video when you're ready to check my work. Okay, so I've started off by just writing out my equation. Going back to reread the details of this, it says she saw she had 3/4 of a carton of eggs. So she had this much. And then she used 2/3 of a carton to make a batch of French toast. So she took away, or she used this much. What fraction was left unused? So I know that I'm going to be subtracting these two things, but look, they don't have a common denominator. We need to create one. Like we did in our earlier problem, sometimes the fastest way to determine a common multiple that they have is to multiply them together. And then you can determine from there if there might be one smaller than that. I'm starting to lose my voice, sorry. Made a lot of videos today. So if we take 4 times 3, we end up with 12. 4 is a factor of 12 and 3 is a factor of 12. Thinking about these two numbers, I cannot think of a multiple smaller than 12 that they both have in common. It is, in fact, their least common multiple. So we're going to use 12 in our new fractions that we're creating. And again, I like to write mine right next door. You can rewrite your problems underneath or wherever it makes sense for you. So I'm just going to ask myself, I need to figure out what my numerators are. I first ask myself, how do I get from 3 to 12? 3 times what equals 12? Well, 3 times 4 equals 12. That's how I got there. I must do the same to the top. 2 times 4 is 8. Okay, there's one of my fractions. Done. How do I get from 4 to 12? 4 times what gives me 12? Well, 4 times 3 does. I must do the same to my numerator. 3 times 3 gives me 9. 9/12. Done. Now I have my two new fractions that I'm working with. If it works better in your brain to rewrite this equation completely with your new fractions, do that. I need to do my subtraction. I know I've done all of this work to find a common denominator. Luckily, that just carries straight over. My denominator on the bottom here is 12, which is actually kind of ironic because we're talking about a dozen eggs. So that's perfect. 12ths. 9 minus 8 is 1. 1/12 of a carton of eggs was not used. So that would be our label. I'm challenging you, though, to think about this a little bit outside the box. How many eggs are we talking about here? So if 1/12 of a carton of eggs was left unused, how many eggs are left unused? This is really our fractional answer, 1/12. If you really think about that, though, it's 1 egg. Good mathematicians are constantly asking themselves, really, what does this mean? Or what is this implying? And that's really what's implying. 1 egg left. Here's where we started talking about comparing. Now, some of you might look at these two fractions. These are fairly common fractions. You might be able to determine right now which is greater or less than. But I am going to walk through the steps of finding a common denominator of these two fractions so that you can very clearly determine which is greater or less. Go ahead and pause your video if you're confident in trying this on your own, and unpause when you're ready for me to walk through this. Otherwise, just continue watching. I'm going to start talking through it right now. So we have 2/3 and 3/4. 3 and 4 are not common, and we need them to be common in order to compare these two. Luckily, we just worked with these two numbers in our previous problem, and we determined 12 was a really good multiple to use. 3 times 4 is 12. That's a good multiple to start with as a common denominator. 4 times 3 is 12. So 3 times 3 is 9. 3 times 4 is 12. So 2 times 4 is 8. So now we can very clearly see 8 twelfths, 9 twelfths. Our answer is less than. That says that 9 twelfths is greater. Last but not least, oh, just kidding. We have two examples left. All right, give this a try. We have 3/8 and 1/2. Go ahead and give this a try and unpause your video when you're ready to check. All right, so good mathematicians are always looking for shortcuts. You don't want to do any extra work that you don't absolutely necessarily have to do. I hope that you noticed at first that when working with the numbers 8 and 2, one of those numbers is going to be able to stay because it actually serves as a common multiple for both of those numbers. 8 is a multiple of 8, and 8 is also a multiple of 2. So saying 8 is also a factor of 8, 2 is a factor of 8. Two different ways of thinking about that. That's a mouthful. But basically what I'm saying is that the 3/8 can stay, and I just need to rename this fraction so it has a denominator of 8. So 2 times what is 8? 2 times 4 is 8. I'm going to do the same thing to the top here. 1 times 4 is 4. So now we can clearly see we have 3/8 or 4/8. 4/8 is greater. Last but not least now, 2/3 and 3/4. Pause your video and try this, and unpause when you're ready to check. All right, so I've set these up with a common denominator of 12. Again, we've been doing some work with 3 and 4, but we've determined that 12 is their least common multiple, so it's a really, really good one to use when finding a common denominator for these two fractions. Now I need to do the work of finding out what my numerators are. So I ask myself, 4 times what is 12? And whatever that is, I have to apply to the top. So 4 times 3 is 12. So I need to do that to the numerator. 3 times 3 is 9. Going over here now, 3 times what is 12? So 3 times 4 is 12. 2 times 4 is 8. I can't help but laugh because I didn't even realize this. I'm almost positive we just did this problem. 2/3 and 3/4.